Glad to see you here. I'm Jia Hui. Today I will be presenting the model training and evaluations of our projects. Without further ado, let's get started. Model building in our projects can be broken down into three main stages, which are the model training using the training set, hyperparameter optimization using the validation set, and lastly, the model testing using the test set. Before we start to train the model, we set aside 20% of the data for testing purpose, while the remaining 80% will be used as a training set and validation set. During the training stage, 4 different types of machine learning algorithms are used to train the model, namely linear regressions, support vector machines, k-nearest neighbors, and decision trees. These algorithms can be categorized into parametric and non-parametric. We will determine which algorithm is more effective in predicting the most accurate outcomes for our problems. After that, cross-validations is carried out to identify the best parameter configurations for each models. In our projects, we apply the tenfold cross-validations and also the repeated tenfold cross-validations. A comparison between these two approaches is made. For the tenfold cross-validations, it is suitable for small datasets, but a single run of the tenfold cross-validation procedure may result in a noisy estimates of model performance. On the other hand, repeated tenfold cross-validations is suitable for small datasets and simple models. Since this approach repeats the tenfold cross-validations multiple times, it can produce a more precise estimate of the model performance. However, it is computationally expensive for large datasets. As we can see from the table, both cross-validation approaches produce the same sets of parameters. After we get the best performing models from the previous stage, we perform an unbiased evaluations to identify the best overall models for our problems. We will check on the RMSE, R-square, and MAE. By looking into the differences between the validations performance and test performance, we can examine if our models suffer from the underfitting and overfitting. This table summarizes the validation performance and test performance when we use the tenfold cross-validations. As we can see, chart is the best overall model as it produces the lowest RMSE and largest R-square in test set. Some of you might be curious that why don't we just use the MAE? This is because the RMSE is more robust in detecting the extreme values. So that's why we will refer to RMSE instead of a MAE. Similarly, when we use the repeated tenfold cross-validations, chart is also the best overall model because it produces the lowest RMSE and largest R-square in test set. As a summary of our presentations, since the differences between the validation performance and test performance are not huge for KNN chart, so we can claim that these classifiers do not suffer from overfitting. However, linear regressions and linear SVM performs badly in both the validation set and test set, so we can say that these classifiers suffer from underfitting. So we can conclude that non-parametric machine learning algorithms are better suited to our problems. That's all for my presentation today. Thank you.